We look at work example number 3. So they want to express 2x squared minus 4x plus 5 in the form of p x minus q squared plus r. Okay, where p, q, r are constant to be found. Okay, so this one, okay, we call it vertex form. Okay, because from here we can know that q, r is the minimum or maximum point. Why it is like this, I will explain later in the other video. Okay, so for this one, there are two methods to solve it. One, for me, I think it's not that proper. The one is using expanding. Okay, the textbook also using that way. So what they do is, but that one is easier lah. What they do is they have the p x minus q square plus r equal to p x squared minus 2qx plus q square plus r, then equal to px squared minus 2pqx plus pq squared plus r. Okay, so for this x minus 2 square, this one I will have the x squared minus 2x cubed plus q squared. So we know that we have the we have the a plus b square equal to a square plus 2ab plus b square. So you should know how to expand it straight without doing the multiplication, x minus q multiplied with x minus q. We don't do that. We just straight write this way. Okay, so you must know this one. Okay, then we can compare the coefficient for x squared. So we are comparing the coefficient of x squared. So when we compare the x squared, then we have the p equal to 2. And then we compare the coefficient for the x. Okay, so we have the negative 4 equal to negative 2p cubed. So the q become negative 4 over negative 2. pp is 2 lah. So we have q equal to 1. And then next we have the pq squared plus r equal to 5. Why? Because this one, the constant number that is the one without x. So this one x squared compare the coefficient of x squared. This one x compare the coefficient of x. This one don't have x, then we compare. So p is 2, q is 1, r is 5. Then we can find out r. R is 5 minus 2, then we have 3. So we have the p equal to 2, q equal to 1, r equal to 3. Okay, so we can straight get this one as this equation 2x squared minus 4x plus 5, 2x squared minus 4x plus 5 equal to 2x minus 1 squared plus 3. Okay, so this is how we do it using expanding method. Okay, but I don't encourage you to do this way lah. I will teach you the other way. We call it completing the square. Okay, but before that, I can teach you a method to check your answer using your calculator. Okay, nowadays technology is, I don't know how to comment lah. So for this one, okay, if we have the a x squared plus bx plus c equal to, we have the a x minus p squared plus q. Okay, we can get the a. This a is this a log, so this 2 is 2 log, then we no need to do anything. So we can know the value of a straight. The second thing, the negative 1 and 3 here, actually we can check using calculator. How? We do use the equation and then the number 2 polynomial degree 2, then we have the 2, negative 4 and 5. Okay, this is how we find the roots. Normally we find the root using this way, but this one is a complex root. It is not real root. But it's okay. Even it's not real root, but you press equal again, then they'll give it 1. So this is x minus p, then that is x minus 1. And then this is 3. 3 is here. Okay. So okay, but for this one, okay, I will prefer you to solve it using computing the square. Okay, so for computing the square, what we do at the first step is we do the factorization of the a. We factorize 2. So when we factorize 2, then we have the 2x squared minus 2x plus 5 over 2. Then some students may have problem to do the factorization. Okay, the concept of doing factorization is very easy. When you factorize 2 here, then every term you divide by 2. Then you have the x squared minus 2x plus 5 over 2 here. Okay, so this is the first step. We factorize a. Then the second step is we have the x squared minus 2x plus negative 2 over 2 square minus negative 2 over 2 square plus 5 over 2. Okay, what we do here is actually we have the negative 2 here. I divide by 2. And then I square and I plus and minus it. Why we can plus minus it? You try to imagine when I plus 1 minus 1, then this one's still the same. Okay, so for this one, I plus negative 2 over 2 and the minus negative 2 over 2. Actually, these two equations still the same, still equivalent. Okay, this one, if we say that this is b over 2, then that is b over 2 again, b over 4, something like that. Okay, so it's easier to say is this term divide by 2. And then you put in a bracket, square it, and you plus it and minus it. Okay, this is a step. So some students may feel curious why we need to do it this way. The reason behind is because we have the expansion of the quadratic equation. We have the a plus b squared equal to a squared plus 2ab plus b squared, right? Okay, so for this one, okay, so these three terms is actually x squared. This one is negative 1 square. Okay, this is negative 2 over 2, that is negative 1 square, plus this is 2x negative 1. So x squared, okay, so this is the x squared, and then this is negative 1 square. So 2 times x times negative 1 is negative 2x in the middle. So these three, okay, we can combine and become x minus 1 square minus 1 plus 5 over 2. Okay, because we have the a plus b square equal to a square plus 2ab plus b square. So you imagine this is x minus 1 square, then it will become x square plus 2x minus 1 plus minus 1 square. Then this one will become this x square minus 2x plus negative 2 over 2 square. Okay, so we do it this way. Okay, normally we do the expansion. So normally what we do is we doing this way. Now what we do is we do this way. We have the a square plus 2ab plus b square, then become this one. So this one become this. Okay. If you don't know what happened here, you can you have the x minus 1 square here. Okay. Okay. So next it will become 2x minus 1 square plus 3 over 2. Then we expand this one. Okay, then we have the 2x minus 1 square plus 3. So this one, x minus 1 square, you don't expand. Huh? If you expand this one, then you will come back to this one already. So you are doing a loop. Okay. So this 2x minus 1 square plus 3. Okay, is this 2x minus 1 square plus 3. Okay, so why we do the computing the square? There's reason. Okay, what is the reason is you can see that we have the 2x squared minus 4x plus 5. So 2, 4 minus 5. 2x squared minus 4x plus 5. Okay, then you can see that 1, 3 is the minimum value. So from here, we can see that this 1, 3 is the minimum value. So just now we have the 2 bracket x minus 1 and square plus 3. So actually these two are equivalent. From here, okay, so from here, we can know that the minimum value is 1, 3. Okay, so we know that the minimum value is 1, 3. Okay, so we will call it the first one, this one, we call it general form. Okay, so for this one, we call it general form. From general form, what we can easily see is the value of A. A is equal to 2, that is greater than 0, positive, then we have a smiley face. Okay, then we have a minimum value. Okay, but the minimum value is what we don't know. Then next is this 5. Then we know that the y-intercept is 5, constant value. Okay, because we have the ax squared plus bx plus c. When x equal to 0, then 0 plus c lah. Then we have the 0c lah. Okay, if you write this way, this one we call it vertex form, because we can easily get that the a equal to 2, then we have a smiley face, then we have a minimum point. So for this minimum point, we can find it when the x minus 1 equal to 0, when x equal to 1. So x equal to 1 is our axis of symmetry. Okay, 对称轴 axis of symmetry. Okay, and the value of 3 here is the minimum value. If A is positive, A is negative, then it will be the maximum value lah. So for this one, we can get 1, 3 is the minimum point. So that's why we call it vertex form, because we can find the maximum point or minimum point in this form. Okay, we call it vertex form. So the step that I'm doing here, okay, the name is completing the square. So for this one, we call it completing the square. Completing the square. Completing the square. Okay, so this is completing the square. Okay, so for work example number 4, they want to find the value of a, b, and c. Okay, fx is a minus b, x plus c squared. So for this one, okay, we have two methods to solve it, like the example number 3. So the first one is they are doing the expansion. So the ff equal to a minus b x plus c squared. Then they have the a minus b x squared plus 2cx plus c squared. Then they have a minus bx squared minus 2bcx. Then we have the minus c squared. Okay, so we have the term a minus c squared minus 2bcx minus bx squared. Okay, so we can compare with this one. Okay, so the original equation, we compare with the original equation. This is the original equation. So we look at this. We compare with the uh, x squared first. So we have the bx squared and minus 2x squared. So from here, we know that the negative b equal to negative 2. So b equal to 2. Okay. And then we have the negative bc. So we have the negative bc to bc is 8. Okay. So we have the negative 2bc equal to 8. So c equal to 8 over negative 2 times 2. Then we have negative 2. Then for the value of the C, B, C, A, okay, so for the value of A here, so we compare this one, the terms without uh, independent of x. So we have the A minus C square equal to 2. So equal to 2 plus C square. So 2 plus negative 2 square. Then we have 6. So we have the A equal to 6, B equal to uh, 2, C equal to negative 2. Then this one, fx equal to this will become uh, fx. So this one, it will become fx equal to 6 minus 2x plus negative 2 minus 2 squared. Okay. Oh, I did a mistake here. So this one, when we do the expansion, so this, then this is bc squared. So it's bc squared. So bc squared. So plus bc squared. So b is 2. So we have 2 here. Okay, multiply with 2. So we have this one 8. Then this is 10. So a equal to 10. Then we have the 10 here. Okay. So this is the first method to solve it. But I will prefer to solve it using completing the square. So method number 2, that is the completing the square. So we have the fx equal to 2 plus 8x minus 2x squared. Then it's minus 2x squared plus 8x plus 2. So what we do at the first step for the completing the square is we factorize negative 2. Okay, so why it will become this? Because when we factorize negative 2, we divide with negative 2, divide with negative 2. So negative 2 divided by negative 2 is 1. 8 divided by negative 2 is negative 4. 2 divided by negative 2 is negative 1. Then the next step is we have the negative 2. Then we have the x squared minus 4x plus negative 4 over 2 square minus negative 4 over 2 square minus 1. Negative 4 over 2. And then this one, negative 4 over 2 is actually negative 2. Then we have the negative 2 x minus 2 square minus negative 2 square is 4 minus 1. Okay, then we have the negative 2 x minus 2 square minus 5. Then we have the negative 2x minus 2 square plus 10. Okay, that is the 10 minus 2x minus 2 square. Okay, so which is this one? Just now this one. Okay, so from here we know that a equal to 10, b equal to 2, c equal to negative 2. Okay, I would prefer doing this way, completing the square. Okay, so over here, actually this is we have the x squared minus 2x 2 plus and then plus negative 2 square. This is negative 2, negative 2 square. So we have the x square plus 2x negative 2 plus negative 2 square. Okay, so this 3 will be combined x minus 2 square and become this one. Okay, because we have the a plus b square equal to a square plus 2ab plus b square plus 2ab plus b square. Okay, and for this one, we have the negative 4. This one, we have the negative 4 divided by 2 is negative 2. And then we square it and we put square it become 4. Then it will become negative 4 minus 1. So if we want to if we want to check the answer using calculator, then what we do is we do the menu, we go to the equation, and then number 2, polynomial degree 2, then the x squared coefficient of x squared is negative 2. And then the x coefficient of x is 8, and then c is 2. Then this is the root, and x equal to 2. So axis of symmetry is x equal to 2. And the minimum point is 10. Okay, so for here, we know that the axis of symmetry, that is the x minus 2 equal to 0, this one. So x equal to 2. And then we have the a, this one, this is the negative 2. Then this is actually a lah. We have the ax squared plus bx plus c lah. Okay, but the ABC is different with the ABC in the question here lah. A less negative 2 less than 0, then it is the concave down. Then we have a maximum value. Okay, so the maximum value is 10. This is the max value. So maximum value equal to 10. So 210 is the maximum point. So we can check it using the decimals. 2, 8 minus 2. 2. So we have the 2 plus 8 square x minus 2 x square. So we have the 10 minus 2 and then x minus 2 square. So these two are the same. So we can see that these two are the same. Okay, and the 210 is the maximum value. So this one. So for part B here, they want us to write down the coordinate of the maximum point on the curve. So this one is actually what I did just now. So I repeat again. Okay, that is, we have this one, fx equal to 10 minus 2x minus 2 square. So we have the axis of symmetry is x equal to 2. Then we have the 210 is the maximum point. So then we can see this is the 210 is the maximum point. So if we write as in the vertex form, then the axis of symmetry is x minus p equal to 0, x equal to p. Then the pq is the maximum or minimum coordinate for the maximum or minimum point. Then next, they want us to sketch the graph and showing the coordinate of the point where the graph intersect x and y axis. So intersect with x axis and y axis, that is very easy lah. So we know that when x equal to 0, so x equal to 0, then we have the f of 0 equal to 2 plus 0 minus 0, then it is 2. So we have the 0, 2 is the y-intercept. Okay, and then we want to have the root for this one, that is the fx equal to 0. So for fx equal to 0, We can use the formula. Okay. So I will prefer you to use the formula lah. Okay. If we don't use the formula, then we can use the computing the square that we have found just now. Okay. Equal to 0. Then we have the 10 equal to 2x minus 2 square. Then 5 equal to x minus 2 square. Then we have the square root plus minus square root 5 equal to x minus 2. So x equal to 2 plus minus square root 5. Okay. So this is the method number 1. We are using the computing the square that we have done. Then we find the roots. Okay. For method number 2, okay, we have the equation, this equation. Okay, then we use the formula. So we use the formula. So we use the formula. Okay, so we use formula here for this one. So this A equal to -2, B equal to 8, C equal to 2. So x equal to minus 8 plus minus square root 8 square minus 4 -2 2 over 2 -2. Then we have the -8 plus minus square root over -4. So we have the 8 square plus 4 times 2 times 2. Then 80. So it will become -8 plus minus the square root 80 is equal to 4 square root 5. 4 square root 5 over -4. Okay, so we divide this one, it will become 2 minus plus square root 5. So plus minus square root 5. So the graph will look like this. So we have the 2 plus square root 5 is 4 point something. And this one minus is negatives. So this is the graph. So we have the 2 plus square root 5, 2 minus square root 5, and then this is 2 when x equal to 0, and this one is the axis of symmetry 210. Okay, so we can see the graph here. Then we have the 210 here, and then this one x equal to 0, y equal to 2, then 2 is actually 2 plus square root 5 and 2 minus square root 5. Okay, and this. Okay, so we look at the last part here. So they want to state the range of the function fx. Range of the function fx, we know that the x can be any real number. This means that the x is from negative infinity until infinity. And then just now, we look at the graph, it will look like this. Then the maximum point is 210. That is, when x is equal to 2, 10 is the maximum point. So we know that the fx here, the larger value of fx is 10. The maximum value of fx is 10. So for d, the fx will be less than or equal to 10. That is the range. Okay. So for the previous example, just now this one, we have the minimum point is 1, 3. So that means the smaller value is 3. So the range will be the fx greater than or equal to 3. So we complete with the 2.2 part. Okay.